Welcome back. Real quick, Miss Wesley here. I could not lose this chance to just show you a few more cool looking polar graphs before we go for today. Looking in the polar packet, page 9, where we left off, just pointing out this is a one-stop shop for a lot of notes about some graphs that we worked with by hand. We plotted points to graph these, so limesons, cardioids, what happens to cause the inner loop. Notes about roses are on here and amounts of petals, circles, lemniscates. You see that all on page 9. But let's end the day with a couple new and cool looking shapes, if I do say so myself. Number 6 says a hyperbolic spiral. We're going to graph r equals 1 over theta. And we'll start on the graphing calculator. So I'll go back to the graphing calculator. If I've put it down for a while, I'll just hit mode, make sure I'm in polar and radian mode for the window that I'm about to use. And my window is set, it's back to factory settings, 0 to 2 pi for your theta min and max, theta step of exactly pi over 24. And my x mins and maxes are negative 10 to 10. If yours aren't, no need to change them now because we are going to be messing with the window on these next few examples. So I'll go to y equals, clear out any equation that I had in there from before, and I'm typing in 1 over theta. But I want to stop and think for a second before we hit graph. We just got done graphing a spiral of Archimedes that went outward because r always equaled some multiple of theta, so it got bigger and bigger. As theta got bigger, the radius got bigger as well. Imagine what happens. This is an inverse relationship between r and theta, right? Each theta, as theta gets bigger, you're putting 1 over that. This is so cool. It's going to spiral inward instead of outward. Hit graph. It's not too impressive when you first see it. It kind of just looks like a shepherd's hook or something curving in, but you need to zoom to really appreciate the beauty of this picture. So I'm going to zoom. Actually, I'll go to window, and I'll keep all this stuff the same. And for now, can you just change the x min and max? Let me go negative 2 to 2 for the x's and the y's. So go negative 2 to 2 x's, negative 2 to 2 y's. Now when I graph this, it still isn't too impressive. I'll hit graph, oh cool, it curves in. But remember in the last, or in some other example, we were able to increase the theta max to make it keep on spiraling in further and further. Let's do the same thing here. Hit window. What do you want to take your theta to? We were taking it to 2 pi. You want to go crazy? We'll take it to 8 pi or 10 pi. Let me say 10 pi. It's going to be my theta max. And then I go back to graph, and lo and behold, it just keeps going and going and going. It would be impossible to perfectly graph this spiral, but Desmos makes it a lot easier to zoom in and out. So if you don't mind, if you want to jump with me to a Desmos window real quick, and we'll get more into this in the next lesson. We'll be graphing some of these things on Desmos. What's cool about it is it switches you to polar mode as soon as you type in an r equals instead of a y equals. And we want to graph 1 over, I'll just type in theta like that. And you see that same picture, but I want to see it move in. Another cool thing about graphing polarly on Desmos is you can hit this little wrench for graph settings that's up in the top right-hand corner. And you can change the grid too. If you'd rather see it as a polar curvilinear grid, you've got all the circles for all the radii and the angle measures in radians going up. Is very aesthetically pleasing. And you can easily, oh my goodness, don't get dizzy now, guys. You can zoom in and it just keeps going and going and going. Now, I'm not too satisfied because I'd like to see it keep going. What do you think I can change on my screen to make that happen? Do you see where it gives you a theta range right underneath the equation? It pops up automatically. This one defaulted to 12 pi. Why does it have to be 12 pi? Can I double it and make it 24 pi? Can I go nuts and go 100 pi? Whoa, it's getting scary. Let me try. Don't do it, Miss Wesley. Don't do it. 1,000 pi. Okay, it's a little bit much for now. Some sort of spider web or like a snail's trail going inward like that. Keep those creative juices flowing. I'll say it again. We're going to work on a project where you're trying to find a real life image in these cool polar graphs. Okay, so that was 1, hyperbolic spiral. To sketch this graph in the space for number 6, I say best of luck because it's basically impossible to draw something that's going to just spiral indefinitely. But I'll draw it coming in and then just curving around the pole. Okay, next up, number 7. E to the theta, it's a logarithmic spiral. Let's see what this one has in store for us, starting with the graphing calculator. So I'm going to go to my y equals and clear out the last equation and replace it with e to the theta. And I want to think about what's going to happen in a second. Will this one spiral inward or outward? Well, R and theta are both going to rise together, right? As you're raising E to higher and higher powers, higher and higher theta values, R is going to rise as well. So something tells me this one's going to need to be zoomed out, and it is going to be zoomed out a good bit. For now, I'll leave my window where it is just to hit graph and see if I get any kind of weird error message. But I need to play with these X mins and maxes as do I with my Y mins and maxes. I want to go negative, okay, this is really crazy. I'm going to go negative 10,000 to 10,000. Call me nuts, right? And then we'll go down and do the same thing to the Ys. Negative 10,000 to 10,000. Do I see much more of this? Is it very interesting or not? I'll hit graph. Okay, you see a good bit more. I don't know, I'm getting kind of impatient. Let me just tag a 0 on the end of each one of these. So I'll do negative a million. That's 100,000. I'm gonna add 2 zeros to make it negative a million to a million. Do you ever graph something on such a big window range? I don't know. Same thing for the Ys. Let's try negative a million so we can really see this spiral. Did I add one too many? 1, 2, 3, 4, 5, 6. Yeah, 6 zeros. And then add 2 zeros to that. All right, we'll see if it looks okay. And I mean, that's pretty much what you're gonna get. It's a little quicker on Desmo, so I'll open a new window and I'll change my grid to a polar and go R equals E to the theta, like that. It automatically takes my theta from 0 to 12 pi. Really, I see the same picture. Zooming out is what does the trick. See if I can get to negative a million to a million. You just see that logarithmic spiral keep going and going and going. Kind of messes with you, huh? We'll leave it at that for now. And I'll sketch my best graph of that too. So it's logarithmic, it's gonna come out and around, and really to see a good picture of it on the TI-84 at least, or on Desmos, you wanna go about a million to a million. And negative a million the other way. Okay, last but not least, you're gonna see one like number 8 for your homework. So I'm gonna change one thing about number 8 in your notes. I'm gonna make it the sine, not of theta, the sine of a half times theta. I want to see what happens when we graph this thing. And what I'll do is go back to my graphing calculator and I'll go to y equals, clear out what I have there, and it said r equals, I changed the problem to sine, I'm in radian mode, of a half theta. I'll say 0.5 times theta for now. Now my window is way too far zoomed out, so I'll go 0. Can you change this with me? For window, I'll go 0 to back to 2 pi, my old trusted and true. Theta step is fine, pi over 24. For this one, you would be fine just to go like negative 3 to 3. A lot of these, if they're not scaled up too high or too low, and especially if they're not spirals that spiral outward, you're pretty safe with like about negative 5 to 5 on these graphs. So I'll hit graph, and I see it looks like a cardioid, and I'm wondering if that's the whole story. Now I want to think for a second. If I raise the theta max, I should see more of this graph. Now, there are times that you just trace yourself over part of the graph that you already have, but think about this equation. The equation was sine of a half theta. What that means is I'm not really taking the sine of everything around the unit circle if I only go from 0 to 2 pi. If I only go from 0 to 2 pi, I'm not getting the full way around. I want to go 0 to 4 pi. Then a half of that will get you the whole way around the circle. So this is just another case, long story short, where if you extend your theta max, you're going to see that there's more to the story. What would be sufficient for this one, because it's a half theta that you're taking the sine of, is to double the theta max and try making it 4 pi. And this should be sufficient instead of 2 pi, and then hit graph. You had the first part, you see the second part comes around the top of it. I kind of consider this one, I try to see real life objects in these, I consider this one like an alien on its side. You see the little eyes in the middle? That's my idea. So this doesn't have a fancy name. We had to increase theta max. We made the theta max 4 pi to be able to see the whole graph. And I'll graph what I call an alien on his side. You get this part of it and that part of it. I am signing off for now, and I hope that you enjoy the rest of your day. See ya.